Hi, welcome back to Math is Blue. Today, our focus is going to be on rational functions. What are they? How do we solve them? And how do we sketch their graph? So, rational functions contain three main parts. We have the domain, we have asymptotes, and we have intercepts. We're going to take a look at how do all three of these things go together and create an incredible looking graph like this. So let's take a look at this. How are these guys going to work? So if we take a look at this little flow chart, we've got our rational functions over here. We'll turn him sideways so that we can fit everything on there. Our domain will fit down here. After we find our domain, that will lead us to our vertical asymptote. These two right here will be closely related. Once we find vertical asymptotes, remember vertical asymptote go up and down. We will look for our horizontal asymptote, which go across left to right. We have two different types of intercepts. We have an x-intercept that intersects the x graph, the x-axis, there we go. And we also have a y-intercept. This is the point where the graph crosses the y-axis. Now I've arranged these in this manner because with our rational function, a rational function has a numerator and a denominator because it is a fraction with x on the bottom of a fraction, but denominators on the bottom. Guess what? Domain and vertical asymptotes, I put those on the bottom because we need to use the denominator of this rational function in order to find the domain and the vertical asymptote. The numerator is on the top of a fraction. That's why the x-intercept is up there. We will use the numerator to find the x-intercepts. Now right here in the middle, we have the horizontal asymptote and the y-intercept. These two are in the middle because in order to find the horizontal asymptote and y-intercept, we need to take a look at the whole fraction, the numerator and the denominator together. So let's get started. Rational functions. Here's our rational function that we're going to take a look at. We have f of x equals x squared minus 2x minus 8 all over x squared minus 5x plus 4. This guy right here, rational. He is a function because right here it is denoted f of x. A function means that when we sketch this graph, it will pass the vertical line test. It will also show that for every x that we plug into our rational function, we will get one and only one answer out. For every x, there's only one y. So let's start with factoring this guy. In order to factor this, we're going to factor the numerator and the denominator. First, always check to see, do we have a common factor up here? Unfortunately, we do not. Check to see in the denominator, do we have a common factor? And we do not. So what we're going to do is we're going to try, not just try, we will. We are going to go ahead and we're going to factor this down into two parentheses in the numerator and two parentheses for the denominator. Now when we factor this, we're going to look in the numerator, two numbers that multiply to give us negative 8, but when we add them, give us negative 2. In the denominator, we will look for two numbers that multiply to give us a positive 4, but when we add them, give us a negative 5. And when we factor, this is what we'll end up with. The numerator will factor to x plus 2 times x minus 4. 2 times negative 4 does give us that negative 8, and when we add these two terms, we do get a negative 2. The denominator will factor down to x minus 1 times x minus 4. Again, when we multiply negative 1 times negative 4, we do get a positive 4. And when we add these two terms, we get a negative 5. So there's our factored form. From there, the first thing we're going to look for is our domain. Our domain, we take a look at the denominator. And what we're going to do something kind of odd at first. We're going to take the denominator, x minus 1 times x minus 4, and we're going to set that not equal to 0. The domain is going to be the list the set of all possible numbers that we can plug into this rational function and get an answer. The problem with a fraction and having x in the denominator is that sometimes the values we plug in here for x will make the denominator a 0. Why is that important? Because we cannot divide by 0. Anytime we divide something by 0, it is undefined. So we have to be careful with that. And the domain is finding a list of all possible numbers. Well, that could be a lot of numbers to go through and check. Actually, too many that I want to find out. So what we're going to do instead is we're going to figure out what can x not be. So we want it to equal not 0. So when we solve these, we will find out that x cannot be 1 and it cannot be 4. Let's try this. If we plug 1 into the denominator, we have 1 squared minus 5 times 1 gives me negative 4, plus 4 gives us a 0. Whenever we plug 1 into this rational function, it will give us an undefined value. The same thing will happen when we plug 4 in. 4 squared is 16, minus 20 gives us negative 4, plus 4 gives us 0. So these two values, 1 and 4, will make our rational function undefined. So we may choose any real number for our domain except for 1 and 4. So there's our domain. Now I told you that the domain and the vertical asymptote are very closely related. Very closely. The vertical asymptote is actually related to what is getting kicked out. What we will do is we will take our fraction and we will simplify him. In order to simplify this, we need to cancel off what is common in the numerator and the denominator. And if we take a look at our factored form, x minus 4 and x minus 4, we can cancel those two terms. And so our vertical asymptote is whatever is left over in the denominator. The factor that's left over is x minus 1. So we will have a vertical asymptote when x equals 1. Now our vertical asymptote is an invisible line. We will represent it with a dashed line. And because it is a line being the key word, our vertical asymptote needs to be an equation. So do not forget the x equal 1. That will give us a vertical line. Now this guy right here, he's important. Because he was canceled with the same term in the numerator, he will create a hole in our graph. So we will have a hole at x equal 4. These two parts right here, when x is 1 and x is 4, on our graph will be undefined. So from our vertical asymptotes, we will go and we'll take a look at, get all this out of the way, we will take a look at our horizontal asymptote. Now when we come to look for our horizontal asymptote, this, remember, deals with the whole fraction. So if we're looking at the whole fraction, here we go. We're not going to actually look at the whole thing. What we're going to do is we're only going to look at the leading terms, the leading term in the numerator and the leading term in the denominator. Now, with our horizontal asymptotes, when we take a look at the terms, what we're going to do is we are going to look at the degrees. And with our degree, in this case, we have them x squared in the numerator and x squared in the denominator. Since our degree is the same, squared, then that means we will have a horizontal asymptote at the coefficients. I know that sounds really kind of confusing. The coefficient here is 1. The coefficient on the bottom is 1. And so we will have a horizontal asymptote at y equal 1. So now we've got our domain. We have our vertical asymptote. We have our horizontal asymptote. What we will take a look at next are the intercepts. We will have two different types of intercepts. We have an x-intercept and we have a y-intercept. When we have our x-intercept, this is where our graph will cross the x-axis. Remember, the x-axis is the one that goes left to right. In order to find our x-intercept, we take a look at our simplified fraction. There's our simplified fraction. Remember, the x-intercept is at the top. He is in the numerator. So we take this numerator, x plus 2, set it equal to 0 to solve, and we will find out that we have an x-intercept at x equal negative 2. To find our y-intercept is where our graph will cross the y-axis. What we do is we plug 0 in for x, take our original function, plug 0 in for x. We will simplify this and we'll find out that we have a y-intercept at y equal negative 2. So that's quite a lot of stuff there. We're going to take all of these pieces of information, we're going to plug them in. Y-intercept, we've got our x-intercept, there's our rational function. Can we see all that? I think we can. We have a vertical asymptote, we had our domain, here's our domain. We had two parts of our vertical asymptote. Remember, we have our vertical asymptote itself, and then we also have a hole. Then our other part that we're missing here is we're missing our horizontal asymptote. There's all of our information that we got from this one rational function. So all of this stuff over here, some of the terms might be new to you, like asymptote, but how we calculated these, that's not new math for us yet. We've been doing that for quite some time. I'm taking you all the way back to Algebra 1. So in this, it's kind of funny on how math comes back full circle. Everything that we've been learning way back, we continue to build on, and it gets bigger and bigger and bigger, and all the pieces come together. So now when we graph this, let's go ahead and get rid of all of these things. We will take our graph right here. We'll plug these all together. I've already put some of these things together. So here we are. We have our vertical asymptote, dotted line, right here at x equal 1. We have a horizontal asymptote right here, green dotted line, at y equal 1. Now, both of those being at 1, coincidental. That doesn't always happen, so don't make that assumption. We have an x-intercept. We have a y-intercept, both at negative 2. Again, coincidental. Do not make the assumption that they're automatically the same thing. Now we have two parts of our graph. We have to have a piece of our graph on the left-hand side of the vertical asymptote and one on the right-hand side. Now what's going to be a little bit challenging is, where are we going to put all this information at? Does our graph come up here, or do we sketch it down here? Do we put a portion of our graph over here, or maybe up here? One of the things to remember is that our graph has to get really close to both asymptotes here. It will not cross it. And so this one over here is a little bit easier to graph because our graph does have to cross through x equal negative 2, and it does have to cross through y equal negative 2. So this one, the only place for this part of the graph to go is right in through there. Now over here on the right hand side, we have part of our graph that could go up here, or part that could come down here. The dilemma, if we use a little bit of logical thinking here, the dilemma with having our graph down here is eventually it is going to have to cross the x-axis. Do we have any other x-intercepts? We do not. So that means our graph cannot exist down here. The reason being is that there is no place for it to cross through the x-axis. So our graph has to come up here. So that's quite a bit of information to piece together. So how are you feeling with the rational functions? Feeling kind of okay, maybe? Let's do one more thing. Let's take another equation. I told you that we were going to do one on our own, and we'll come back together and we'll take a look at it. Here's our function equation. This guy right here, f of x, he's a function, equals 2x squared plus x minus 3 all over x squared plus 4x minus 5. Now, a little bit trickier because we have a leading coefficient. So from here, go ahead and pause. Remember the things that you're looking for. You're looking for the domain. You're looking for the vertical asymptote. Horizontal asymptote, you're looking for the x-intercept and the y-intercept. So go ahead and pause for a moment as you work this problem out, and we'll compare our answers. Now, did you get a graph, a sketch that looks like this? If you did, awesome. I knew you could do this. Now, if you didn't quite get this one, let me go ahead and show you all the information with this. There's everything we should have gotten. We should have gotten our domain to be all real numbers except for -5 and 1. We should have gotten vertical asymptote to be -5, a whole at 1. Horizontal asymptote, y = 2. X-intercept at -3/2 and y-intercept at 3/5. Now, one of the things that may have thrown you off on this one, I told you, a little bit trickier, leading coefficient here, is how we factor this. Did you factor this guy to look like that? If not, I bet that's where the dilemma is. Anyway, I hope you had a good time with Math is Blue. I hope you understand a little bit more about rational functions. Have a wonderful day, stay strong, and math on.